Why does this give me two screens?
Hello there.
Hello.
Hi.
So how's everybody doing?
Yeah, not bad. Tired. How about you?
Doing all right. I had started working from home just a little bit before this pandemic, and so kind of smooth entry. Now it's just feeling like I'm never going to go back to an office again. I'm just going to be work from home forever.
I've been doing it for a decade, so
Wow.
yeah, I'm not big on offices. It's nice to have the company sometimes, but I just don't feel as productive when I'm in an office
Mhm.
environment. I always just want to talk to everyone.
Yeah, that's true. Yeah.
I'm just going to dash away for a moment. I've literally just finished my workday.
Seeing you eating makes me hungry. I'm going to go get the bite.
I don't know what time zone you're in, but it's lunchtime here.
Hey, I'm back. There is actually another Zoom channel as well, the one Ivan set up.
Another Zoom? Is
Yeah,
this the right one or the wrong one?
there is another one. Is I popped on there just now, but it hadn't started up yet. So hopefully no one's using it and they'll all come here, but not sure. I posted it in the thread anyway, in case anyone had gone to the wrong one.
We're only waiting for Lee, so he'd be the only person we might have to find.
Well, I'm happy to hop over there and see if he's on.
Might not be a bad idea.
All right, I'll do that now. Yeah, he's just going to join.
All right. Hello, everyone. Then.
Hello.
Hey,
So forgive the children's cartoon noises in the background if they pop in and out.
likewise. I'm in the same position.
Yeah, so some of those songs that like the theme songs are just embedded in my brain.
Yes, that's right. I know all the Mickey Mouse songs.
Cool. So we got everyone.
Where to start?
Yeah, where to start? Some kind of overview or quick review of the solutions that each of us are considering, perhaps, or maybe talk about how this meeting will go and what kind of result we'd like to have it by the end.
Has everybody
Sounds good.
read through the list of options recently, or would it be useful to go through them all and just talk about them all in like super high level?
Yeah, let's do that. Does someone want to share their screen so we're kind of like looking at it at the same time? Same point in the doc at the same time.
Let me see if I can do that. Desktop 1. Okay, I cannot share my screen without rebooting my Mac because security.
Because updates.
No, because OS X security reasons. Yeah. So somebody else can
And then,
go right ahead.
oh,
Making an attempt.
same here, security, huh? There we go. I see a
Did
screen.
that work?
Did.
All right, cool. Yeah, luckily I had to do a Zoom call and present not that long ago, so I had to go through that whole rigmarole. You like eventually have to either reboot your whole computer, or if not reboot, just Zoom, but it's annoying. Every time your OS upgrades, you need to like re-permission everything.
Yeah.
Okay, I think problem statement we're all familiar with.
I would hope so.
Problem sketch, I believe we're all familiar with. Someone just shout stop when I get to a place that we should start discussion. And talk about prior art, maybe. Has this expanded much?
I don't think it's been added to very significantly, but
Okay. I actually think prior art is a pretty interesting place to spend a little bit of discussion, because it makes it clear that none of the proposals that we're considering are sort of like the unanimous standard, that different systems have arrived at different results, likely due to different trade-offs. And they're mostly some combination of, what does Captain Proto decide for unions? These are not perfect comparisons, right? Because
they're often definitional instead of transport layer stuff.
yeah,
exactly.
yeah,
Yeah, I think that's a really critical thing to think about. Like, there's the specification, the types themselves, and then there's the transport layer, right? If we had like a binary serialization transport layer, this would be trivial.
right.
It's the fact that we have to actually like convey more meta information in the transport.
Yeah. And we need to be able to translate between other forms and GraphQL, most notably JSON. TypeScript's interesting. TypeScript's the one that I think is most interesting to look at because it's so close to kind of what we're doing, you know, like laying a type system over being able to prescribe JSON. Oh, thank you.
Nice.
Toast delivery. See if there's any other wacky ones worth discussing. JSON schema and OpenAPI are also, I think, very relevant. Very similar kind of form, right? Like looking at input JSON and trying to overlay types on top of them.
Yeah, those don't have any concerns with sort of verbosity though, because they're just overwhelmingly verbose to start.
To say the least.
Yeah.
Oh, I see this one of. Every time I see one of, I think of the one of directive, but this is much closer to a union. Okay, those are the Rust and like Haskell family are the most interesting, but they like smush enums and unions together as well.
Yep.
Super useful, but
yeah,
maybe even less likely or less related to what we're doing. Okay, use cases, building ASTs, observability metrics. That's interesting. Filtering, I've seen that one show up a bunch. Okay. Solution criteria. Actually, maybe it'll be helpful just to like walk through the solution criteria and just gut check the criteria scores that we have.
Yeah.
And make sure that they mean what we think they mean. The premise of the RC, GraphShell should contain a polymorphic input type. I think we all agree about that one. Input polymorphism matches output polymorphism.
This is the one that I talked about in Slack briefly yesterday. I don't know if you saw that thread, Lee.
I did not see that thread yesterday.
There seems to be kind of two different things that people are trying to capture with this criteria. One is that like if you get a union back from your response from your server, then that kind of looks like what you would send in for a union on the input side. And then the other thing is the other thing that you can sort of try and capture is this idea of symmetry, of like less from a kind of type and payloads perspective, but more from a behavioral perspective. Input and output unions are symmetric.
Yeah, and I mean, I think both are valuable, but I would say that this is the primary driver for me altogether is, can I like give the user of my API a good experience when they're operating on some data structure and they want to pull it down and then make a modification and push it back up without having to do massive amounts of transformations tangential to the change they want to make. So that's like, from a very practical perspective, that's like why I'm here.
Oh, okay. There's some nuance to this one, because the practical concern, Vince, that you mentioned, first of all, I 100% agree with it. And it's also a little bit different than the abstract idea that there be symmetry, right? I think instead, maybe what I'm hearing is that you want anything that you can express in output polymorphism, you should be able to express an input polymorphism. But the other way around might not necessarily be the case, if that makes sense. Like input unions have to be at least as flexible as output unions, but they might be able to be more flexible.
The way I understand Vince's point is not just about whether it can be expressed, but that it is expressed in the same structure.
Yeah.
so
Mhm.
that the client doesn't have to like translate between them.
Right. Yeah. So for example, like tagged unions, like there's a massive transformation that needs to happen to the data structure itself to like take it and use it in both sides, so to speak. But it's like theoretically symmetrical in that you can represent, I guess you can say you can represent the same data structure, but practically it's like they're just different.
Right.
See, I'm not in agreement on that being a massive transformation. I actually think that it's less of a transformation because you literally take the output object and you can send it back with a wrapper rather than by actually going in and modifying it, for example, adding a type name or an input name or something like that, or a discriminator or whatever,
But
which
if
is
it's
actually modifying the object. This isn't, it just
what if
wraps
it's
it.
nested though?
Yeah.
If it's like if they're in nested positions, it's one thing if it's like the top level object is a union, and wrapping it then is trivial. But if you have like 3 nested objects at various depths, each of which are
Arrays of nested
unions,
objects.
yeah, then like
we have that.
then the like
Yeah.
code you would have to write to transform that is maybe stops being so trivial.
Yeah.
That's a fair point, and yes, it definitely gets a bit challenging once you've got 3 levels deep of it.
And so an example for us, it's not common, but like, so for New Relic, monitoring, observability, whatever, we have an API that lets you set up an integration with a cloud provider to pull their metrics. And so we have the top level is like all the cloud providers, AWS, Google, blah, blah, blah. Then one more nested level is all of the services they have. And then inside of that, there are whatever shape of structure they have. So like it's super nested and complex, and there's hundreds of things. So writing a client for that would be non-trivial.
And is this use case common that they write a query to get a fairly large structure and then make some internal modification to it and then send that back as an input?
Yeah. Yeah. So it's like you want to, yeah, that's what you're talking about. Things like polling intervals on this particular metric or some setting for like how much of it or which fields to ask for. So yeah.
It's interesting because I very much feel the pain on the nesting, and like Shopify's schema is huge, and so we deal with a lot of that. But we also are very much not doing the like send it back verbatim thing. We expect the client to like at the very least pluck out the fields they care about when they send it back. And so the idea of like throwing a type name into the input payload to disambiguate is like not a problem for us from that perspective.
So a way to think about this is like, it's to some degree trying to enable some stuff that's super easy in REST. And like, I don't know if y'all are familiar with Terraform, the tool for like infrastructure as code. Pretty much all those things are like, pull it down, compare it to the state, make the modification and push it back up. And that's like the kind of pattern we're trying to enable across all the things that we manage, like all the data structures that are like configuration of a thing.
In REST, we've found that to be a really bad pattern because you end up sending.
It's the thing we have to implement though.
It's true.
I have seen both patterns, and like you end up recommending each pattern differently depending on this kind of system that you're working with. There certainly are systems where the best operating model is you have these kind of structs and sometimes nested structs that you only want to think about holistically. Like there's just a new one and you use the new one now, as opposed to thinking about them as long-lived objects with modifications over time. In which case you would want like subsets, or like, this is the field I want to mutate. Facebook didn't really have this kind of like large struct pattern in many places, but it did have it in a small number of places in internal tools. So the idea that you would see it a bunch in something that like looked like Terraform makes a lot of sense to me. For some historical context on this one, when I was working on input objects, there was a question about whether those should also have this like input output polymorphism. We like there's an original pushback that like maybe like are objects enough? Like, do we even need input objects? Can everything just be plain object types? And you know, if your object type has an argument on a field, then you just can't use it in an input. It's like that just got too confusing, and so we made a separate concept. But we still kind of arrived at this idea that most of the things that you can express in a output type, you should be able to re-express as an input type. You know, so there's and unions are the like missing piece. So it's not surprising to me that we're now here talking about unions. In terms of this idea of being able to like send back a similar shape to the thing that you receive. So I buy the argument that polymorphism is important.
Cool.
Cool. Should we keep reading?
Yeah, let's move on.
Does it inhibit schema evolution? Adding a new member type to an input union or doing any non-breaking change to existing member types should not result in a breaking change. For example, adding a new optional field to a member type or changing a field from non-nullable to nullable does not break previously valid client operations. That one sounds right. I think we had a discussion in the last working group that we're still have not really defined very well what breaking means. So I think as we evaluate this one, we might need to be a little nuanced. But certainly I think it's hard to argue against this being important. The reason why I suggest that there's probably nuance here is with output, breaking is fairly obvious because you're going from a GraphQL representation to whatever serialization you're using, JSON. And the shape of that JSON needs to be the same as the schema evolves. Otherwise it's breaking because the client is going to get a actual different, like the tangible payload that they receive will differ. But for input, it's a little bit, it's like the other way around, right? Like the client is going to give you some serialized payload, probably JSON or whatever. And then the server needs to be able to interpret that to mean something. So it's flipped around. So a lot of this is kind of up to us with how we describe the way that we expect servers to interpret inputs. But certainly if they interpret it in a way that results in different behavior, then that should be breaking. Any other nuance people have spotted with this one? Cool. Member type restrictions are validated in schema. If solution places restriction on the member type, compliance with this restriction should be fully validated during schema building. What does this one mean?
I think it's something like you shouldn't be able to create an invalid schema.
Oh, okay. Well, yeah. Yep.
Like embed the rules in the structure of the schema.
Perfect.
If there are rules.
Okay, this one's fun because there's lots of red X's. A member type may be a leaf type. So in addition to getting into objects, a member type may also contain scalars or enums. And then there's a bunch of objections here.
Yeah.
So this is when we were having the previous discussion about input output polymorphism, this is the thing that popped up most clear to me is there are going to be cases where you want to be able to represent the difference between a single case or a multi-case. We already kind of support this out of the box for arrays due to I would say a hack where you can use a single value to express an array list of one. But I suspect that there are cases where you want the same kind of flexibility, but rather than flexing into an array, you're flexing into an object. So you want to be able to say, you know, you're either like, I only care about this one field, in which case I'm going to give you a scalar, or I care about lots of fields, in which case I'm going to give you an object. And for the idea of, you know, this terseness or being able to to sort of like represent it in the way that you think about it, and avoiding wrappers if that doesn't match your mental model, then this is a very convenient thing to have. The basis for this comes from the use cases that we've seen in the past. So like the very first arguments for input unions were a result of people trying to write filter APIs for like a SQL wrapper. And you end up wanting to write like and or rules. And so it's like you either can have a string for like a string match, or you can have like a and rule that's like an object that then fans out. And so this was the very first proposal for this included this as a criteria. So that's where it comes from. But
it's not just for complex filtering like that arguably shouldn't even be in GraphQL. But it's also for things like if you want to, for example, just pull down one record, but you've got a number of different types of identifiers for it. So it might be pull down a user by their node ID, or by their username, or maybe by their email address, if all three of those things are unique identifiers for that person. And exposing those as three separate fields is kind of messy, especially if you do that for more than one thing in your schema. But similarly, we don't have a way of saying you only need to specify one of these things, or you need to specify exactly one of these things, which is really the issue. Like a union would solve that. It's this or this or this.
And confirm that Shopify's schema has a million like lookup X by Y fields on its root for exactly this purpose.
so does Facebook's. Yeah, I hadn't considered that,
I
but
think
actually
that's
I really like that pattern.
Sorry, yeah. I think it's more of an issue than the actual bigger filters. Because yeah, a lot of people are using the lots of fields pattern.
And are you suggesting that that's relevant in this case because one of those is going to be the dominant case, and you'd want to like get by ID is just the ID, or get by username might be an object where you say username colon some string,
Or just they're all different scalars.
They may not all be scalars. Like it might be, say, the organization ID and the identifier within that organization, for example, like a government ID or some kind or something. It may actually be a list of scalars. It may have objects as well. I don't have all the use cases in my head right now. I think I've had ones where it's been objects before, but I can't think of them offhand.
So when I've thought about this, the primary objection I've had is the second one, in that output polymorphism doesn't have this capability.
Yeah.
And so adding it would mean now that there's an asymmetry. But Lee, you mentioned something earlier, like maybe that's fine. Maybe like we get to a point where they share this base level of capability now.
Yeah.
And then input unions can do like this one extra thing. Will that push people in the future to want to let objects polymorphism do the same?
People have already been asking for that.
Yeah. I think
people have already been asked for that.
Yeah, I think the additional restriction that puts on then is that if we allow this on inputs, we have to allow it on inputs in a way that is extendable to outputs.
That's a good thought. Yeah, or at least we should be careful that we're not making a decision that would limit us from creating asymmetry in the future. Yeah. But it doesn't bother me that, I mean, output types can do things input types can't. It doesn't bother me that input types could do things that output types can't either. But the original reason why output types did not allow scalars is this was a world before clients having strong type systems. Like you land these in an Objective-C code base that's like entirely dynamically typed, or like a pre-TypeScript or Flow JavaScript code base. And the first thing you want to do is like test the type name field to see what to do. And scalars don't have that.
Yep.
The other thing that gets complicated with output unions is knowing whether it's expected or allowed to have a selection set. So what does it mean to have a selection set on something that might be a string? We could come up with rules for that. Like you could say like, oh, we just ignore the selection set in that case. But it is like, because those were confusing, we just ditched scalars from output unions. I think input unions don't have quite the same number of potential like things that they bump into. So I think even in a scenario where we go back and look at output unions and say, no, still super weird, I don't think we want to do that. At least personally, I'm still comfortable with that inconsistency, as long as it is valuable and doesn't break things for inputs.
I think the first objection is still pretty meaningful though. Like, how the heck do you tell the difference between a string, an ID, an enum, or someone's custom scalar that serializes as a string?
I think that's a great objection. If anything, it might mean that we need to restrict these. And if you look back at the use cases that have demanded this criteria, I haven't found any use case that asks for multiple of these. And so,
Right, so the single,
like, that's one potential solution, is to be just like input unions can only have one scalar.
one scalar.
Lookup X by Y fields, at least the way we use them, would definitely benefit from multiple scalars in a union. But
Lookup X, what would
you
be
custom scalar to signify something?
we have some custom scalars. We have some, like, as Benji mentioned, email addresses and other, basically other stringable fields you can look up stuff by, which probably, like, on syntax alone are disambiguous from IDs, but not at the schema level on the transport.
Yeah, disambiguation gets tough, especially if you end up in situations where it can be either. So I think this is actually a case that I personally feel like we should not support at the spec level, is disambiguating based on like a shape of a scalar in order to affect behavior. It just feels too fragile to me. It's too easy to like miss something where there's potential overlap between the two.
Yeah,
I agree. It needs to be labeled in some way. It can't just be the scalar value itself.
yeah. If multiple scalars in a union, it has to be via some sort of label.
And
right. Then we're just into the type. The same problem as everything else is like, how do you transport the type?
Yeah.
Yeah.
And so if we did want to support multiple scalars, then like we would have to be okay with the end result that like the server might not be able to differentiate between them, and that doesn't sound like an outcome we necessarily want, So if something is like a string or an ID, really all that means is like it's probably a string. It's like, well, it might be an ID, that's allowed, but you don't really have any information to disambiguate this. Or even like string or enum is like kind of hard to differentiate between if the string is the serialized form that takes. The dog is freaking out. I saw a squirrel. Okay, we can move on. Migrating a field to a polymorphic input type is non-breaking. Since input object type is now a member of the input union, existing input objects sent should remain valid. Okay, so this is about the idea of, GraphQL 2021 introduces input unions. You're like, hell yes, I can't wait to use this. Here's a field that accepts an input object. I'm going to transition that to an input union where that input object is one potential member, but like now here's the second member. Does that break things? Is that the correct understanding of this criteria?
I think so.
Yeah, like, does it break the behavior?
Mm-hmm.
The interpretation, yeah. And I think this is a nice to have, but like we shouldn't block on it. There's many changes that you could make to your schema that like are breaking. I think, like in my mind, that's that shouldn't prevent us from choosing a solution.
You may be right. I think from a practical point of view, people will be excited about this. And maybe a way to think about this is like the principle of least surprise.
Mhm.
If they say, okay, you know, this input object here is like field X takes a string, and I've always wanted to add it. Field Y takes an int, but I've needed input unions and now they're here, so I'm going to make that change. And all of my existing clients are sending field X is a string, so they should just keep on working. It may be surprising to learn that that is actually breaking, and maybe hard to explain why that is breaking.
It would, yeah, it would be.
Yeah.
I mean, I guess the break is there. The break at that point is the change being made to the schema. So like you could have a, like the other rule earlier, like not allow that. Well, I guess it's hard. That's
Yeah, I mean,
hard
I
to
agree.
express itself.
If we could satisfy this one, my suspicion is that all of the, well, without getting too much into what the actual proposed solutions are yet, my suspicion is that we will have to sacrifice this one, because it's. But
Yeah, I see mostly green checks with like combinations of scary marks. So
yeah, I think
Yeah.
it's mostly too
it
optimistic.
could be that we like partially support this, but like
I don't know what.
explain in what scenarios this migration is breaking.
Yeah, as far as I know, all of the ones that have the yellow triangle in this are actually on a literal interpretation, just breaking and not supported.
Okay.
Yeah, there's like caveats to what you have to, like you have to have some extra aspect to the solution to try to enable it. Like adding a default that's the original or something.
Yeah, that doesn't sound great. Okay. I'm hesitant to just like decide to punt on it because I do think people will want that upgrade path, but
Yeah.
But I hear you. Input unions may include other input unions. This one, are we just like striking this in this criteria? This one looks unfilled.
Yeah, it's been proposed, but really like high level. It's like, yeah, this would be cool, without giving it the due that it has. Like it seems to me like quite a complex thing to tackle.
Yeah.
And no one's put forth any like more detailed approaches. So
yeah,
this is kind of like the interfaces implementing other interfaces. It's like the mirror of that. No one's come forward, as far as I know, with a concrete like this use case demands this feature, but equally there may be one that comes down the line. So I wouldn't completely ignore it. That said, I mean, we haven't even bothered evaluating it for any other solutions. So yeah.
It sounds similar to the idea that output unions should be able to include output unions. This comes up as a point of contention every once in a while, but it was a very explicit decision not to allow that. And it was a trade-off between development ease and readability and like simplicity.
Yeah.
It's kind of nice that you say like, what are all the potential members of this union? And like, there they all are. You don't have to go like follow a hop of another union to find them all.
Yeah. I mean, one of the best things that happened in my career is I stopped working in an OO language and I don't have to do inheritance anymore. So I'm like, ah!
Yeah. I vote that we don't worry too much about this one.
Agreed.
Input unions should accept plain data. Clients should be able to pass natural input data to unions without especially formatting it or adding extra metadata. So this sounds very related to the point we were discussing earlier, the criteria B of whether or not you needed to wrap something that was nested, or like an isomorphism with an output serialized shape. So I think we can like ask ourselves what we mean by natural. I think natural probably just means the conventions that people typically find themselves using when they express their data in JSON or whatever serialization language their server uses. But certainly, first and foremost, that would be the serialization form that comes back from a GraphQL server. And matter of taste, do you all agree with that objection that it's a matter of taste, or does that framing change now that we've like talked through criteria B?
Taste is maybe the wrong word, but I think it's valuable to note that like a lot of other solutions have traded off this criteria.
Mm-hmm.
They sort of have, but some of those are not transported with JSON. Like some of them are binaries, so they haven't had to give on this one. I think this one is like trying to express something that's meaningful, but also just a little off with like calling stuff natural and like saying things are a matter of taste. I think there's a very real practical concern of like, what does it take for the client to implement this sort of back and forth type of transformation? So, yeah. And there's scales of it, like there's wrapping objects in other objects. That's a certain scale of the transformation that has to happen. There's adding a single type field. That's like another scale. And then there's like not having to do any transformation to it. So I think we should keep it in mind. I think it's core to but I don't think this particular item is expressed super clearly.
I definitely agree with you. Like using words like plain or natural, like these don't have consistent definitions. And so based on that interpretation, it's not surprising to me that the objection here is about opinion. Mm-hmm. I actually really like your reformatting of this as a thinking about the amount of transformation that needs to happen to data that may have come from another source.
Yeah.
Yeah. You could also frame it as just thinking about the amount of metadata that has to be sent on the wire.
Mm-hmm. Yeah, minimizing metadata. Okay. Is it worthwhile to make these edits live?
Oh, I started taking notes, but the earlier parts I didn't write down.
Here, so I'll just open this in another tab. That way we don't have to lose our scroll position. And then that way, as we talk through the stuff, we can make notes. I'll try not to delete, but in other words, data should require minimal or no transformation and metadata over the wire. Is that a good re-encapsulation?
Yes. Whilst you're there, should we look at potentially like removing or putting a strike through criteria G?
Yeah. Criteria score, I'm just gonna replace this with an X.
Cool.
Okay, back to visible one. Input union should be easy to upgrade from existing solutions. Is this a repeat of F?
I think mostly.
Looking at the like criteria matching, it's a perfect match.
Yeah, they are distinct requirements though, or criteria, sorry. The first one, F, is about if you have a single typed field in your schema and you want to make it a union, how do you do that migration? I is about you're already doing fake unions in your schema today and we release unions. How do you make them use real unions?
Yeah.
Oh, okay. So say for example, you're accepting a input union or you're accepting an input object with two fields, X and Y. X takes a string, Y takes an int, and you've just like had a gentleman's agreement with your clients to only send one field at a time.
Mm-hmm.
And now you're going to transition that to a union of an object with a single field X and an object with a single field B, or using this like one of flag that requires the implicit agreement, is that considered breaking, or is that a allowed migration? Is that right?
Yeah, is that easy / possible / non-breaking?
Yeah.
I'm gonna just like write this as an example here. From input I string int to union to, I'm just gonna say input union I is X string or Y. This does not match with any of our proposed code. It's just a way to think about it.
Yeah.
Okay. And the other one, I'm just gonna paste in here so that did I do that before the objection? I did.
I think a
Okay.
good example for the other one would be like a relay mutation, where you want to take the input object and turn it into a union of possible input objects.
For F or for
This
I?
is
For F, yes, for F.
This expresses it well though, because
For F, I'd say it's more about changing the field that returns type I rather than changing, like it's more returning like field F returns I to field F returns some new union that includes I.
Yes, exactly. But
That
really,
would likely be the case in both of these, right?
No.
No,
Well,
because this type would be a newly named type, right? Oh, I see.
yeah,
This
yeah, I
one's
think
like
this is accurate.
yeah,
Because
yeah, exactly. That's
Okay.
right.
And this one is okay.
No, this one
Okay.
would stay with the same type name potentially, or yeah, okay. No,
Yeah.
I'm not sure if it would.
Maybe, yeah, it may or may not. The type name might change. So far, the type name for inputs is like a warning, but not a breaking, because people don't include them anywhere, but definitely useful to know.
In
Okay.
variable definitions, they would.
So
if you take a variable like
yeah.
$, input.
Yep. Does that change? Yep. I'll just post those in both. It's a good thought.
that's important.
So in F, I don't think it would break anything, because you'd effectively be saying that IU is an I or a X, whatever. And so if you just say the variable is an I, it's still within IU, so it would still be fine.
Yeah, that's a really good point.
And also
Okay.
for the other one, if you keep the variable name, if you keep the union called I, and you actually rename the input type, then you can still specify it the same as well.
Yeah.
So both can be achieved in a non-breaking way, I think.
Unless you have directives on the input that only apply to input objects and not input unions, which seem like they could potentially be a thing, but like that's really corner casey.
Yeah. Okay, that's good to know. I do think like once we arrive at a final solution and this all gets nailed down, we'll need like a whole guide on like how to adopt these from an existing schema. And all of these things that we're bringing up are like special things to take care of. All the more reason why we should actually define what breaking means and like write
Mhm.
consistent software that people can use. A GraphQL schema that supports input unions can be queried by older GraphQL clients. That's 100%. Yeah, hard to argue that. Input unions should be expressed efficiently in the query and on the wire. This also sounds like a similar reformulation of H, or maybe even B. Is that right?
I think this actually arose someone who was concerned about like actual server side performance implications.
That's L, not A, not K.
Oh yeah, maybe these came together.
Yeah, I think because I think I was involved in those. I don't remember if they were mine originally, but I was involved. So yeah, performance came up specifically for like actual server compute performance.
Mhm.
At least one solution that was proposed at one point that would have been like algorithmically expensive. And then so I threw in L, which is for that, and then I think I threw in K just to go with L.
Got it.
It's true, but probably not useful.
Okay, so this criteria is expressly about the efficiency of bytes
Yeah,
and not about the like human eyeball idea of efficiency,
no,
but the like performance of bytes on the wire.
it's a reason to exclude solutions that would triple the size of input unions on the wire for some bizarre reason. But whatever, none of our solutions.
Okay.
I think we
Because
basically decided that all of the proposed solutions pass this criteria because you're probably going to use gzip encoding, in which case they're all basically the
Well,
same.
all of them pass because none of them add more than a handful of like strings to the payload and nothing.
And
yeah,
and they all add linear strings too, right? It's not like if you had an input object with 100 fields that it 2x's in size, it'll increase in 30 bytes or whatever.
it's all linear.
Or a constant, I should say, not linear.
Tagged is technically linear on the number of different unions, but like low linear because you have to give a name for each
Right.
union. But whatever, like still not a big deal.
Ideally, a server does not have to do much computation to determine which concrete type is represented by an input.
But this one's
Yeah.
to discourage sort of walking the tree of types to see which is the first one that matches. I think that was the impetus for that rule, I think.
Yeah, there's, I don't remember if that's 3 or 4, but at least one of them was like do some non-trivial work to like match it against the various options to figure out which one it should be.
Okay.
And that's, again, probably like as expressed in the solution, not a big deal and probably fine, but I wanted to, call it out as complexity and performance here, especially like in the long tail of a union with 500 possible types. That could actually get expensive.
5,000 possible types.
5 million possible types. I don't know.
Someone's going to do it.
Yeah.
I kind of agree with this objection that none of the solutions are asking to do anything beyond something that's linear to the number of unions or members in the union. But yeah, what do y'all think?
I think that just means they all pass right now, or at least they all pass with minimal caveat. Not an objection to the criteria so much.
I don't think that's. I think many of them are O1. Like they literally, it tells you the type right there, and you can look it straight up. You don't have to do any comparison. Whereas one of them, you actually have to do ON, where you have to look at every single type in turn to find the first one that matches.
Yes,
that's again. I can't remember.
Yeah.
1 and 2 are definitely O1, so they 100% pass.
As is 5.
I don't remember which of 3 and 4 is linear.
I'm gonna do this. Let's see, where are we? L. You can just go.
So
Possible.
I don't.
Discriminator.
I tend to think this is not very important because there's already some like non-trivial validations that are done in some cases, like
Mhm.
cycles, fragment cycles, and some of that stuff has like meaningful computational complexity, but it's like compared to other things that these servers do, it's like nothing. So I would say like validating analyzing these is good, but it's not going to matter.
Hey, just as a slight
real world.
I
challenge to that.
kind of agree with you.
The slight challenge to that is all those other sort of fragment things are done at validation time, which can be cached for the same query. So
Fragment cycles within the query document supplied still have to be analyzed.
Yeah.
It's not at the schema. It's actually of the query document.
No, that's what I mean. But the validation phase of execution, validate, pass, validate, execute.
Stored queries can cache away those validation issues, but they cannot cache away input union choice.
Yes, they can't cache away the input union value validation because that has to be done at execution time.
Yeah, but I tend to agree. I think
It's a minor point.
we should be helping protect our users from like super linear performance, and there are probably cases where we can there are super linear performance issues that we should help them solve. I don't think this is one of them. We could even run like, I don't know if someone wants to prototype some of these in one of our reference implementations and just like look to see how tricky it is. My expectation is that it is not going to be a serious issue, but I'm glad that we're documenting it. So 2 of these solutions are ON and 3 of them are O1.
Cool.
Okay, we are on M. Existing SDL parsers are backwards compatible with STL additions. And the last one is the only one that passes this. I'd argue that this is going to be like criteria 3, if not criteria 2. Every other thing that we've added to the language in the SDL has included new SDL syntax, and that has not been an issue in the past.
Speaking as the champion for number 5, I don't think this one is important at all. I think we should remove it.
Oh, remove it completely.
Yeah, I'm happy to hear that. I actually like knowing that we're okay with evolving the SDL language itself is great. So
I'm just going to document these. So this is kind of a form of note taking.
Cool.
Evolution of the SDL is expected with new features. I also kind of want to document one more. Let me say it out loud before I write it down, so you guys can tell me if you agree. There's something that's nice about if the syntax is new. Say I have a server that accepts SDL to turn it into a schema, and I give it an input union, and it doesn't know about input unions yet because it's like on an older version. It's going to look at that and be like, I don't know what you're talking about. And I think that's actually valuable, right?
I gotcha.
Whereas if it's something that's purely additive or something that's directive based, it will look at that and be like, schema granted, here you go, start working with it. Mm-hmm. And that might give me false confidence that I now have a input union at hand when I might not.
Yeah.
It's kind of edge casey, and like I don't view that as a strike against solution 5 in any way. But I just want to like note that as a counterpoint to this idea that the SDL having like syntactical breaking changes is a bad thing. I think you could kind of interpret it as being a good thing.
We
absolutely agree. I'd also like to point out that solution 5 could be done just the same using a keyword versus a directive.
Yeah. Totally true.
Yeah, I appreciate that. It's the fail fast, don't operate on bad data structures or unknown state. I like it.
Come up. Our internal debates about what a breaking change is, because there are a lot of those as well. We've kind of split this out as explicitly versus implicitly breaking changes. And definitely, like, we've been recommending internally, people prefer explicitly breaking changes because explicit is good.
Okay, cool. Glad we all agree on that. Existing code generated tooling is backwards compatible with introspection additions. So this, am I understanding this correctly, that this means that we just shouldn't produce breaking change to introspection?
I think that's already like an aim of GraphQL, right? Like if you take an old graphical and you point it at a new GraphQL schema, it should still work.
Yes. There is an interesting question here, which is, what does that mean as we introduce new kinds of things? This would be, I think, the first time that we introduce a new kind of thing. So like we added the ability for interfaces to implement interfaces. That was just an additional field on the interfaces, and things kind of kept working because old tooling just wouldn't query that field. But if this comes back, in the introspection schema, there's a field that tells you what kind of type it is.
Yep.
And presumably a lot of these, probably all 1 through 4, would have a new type.
Yeah.
And clients might look at that and say, I don't know what to do with this.
I know that.
I think that
when I
should
pointed-
generally be okay, in the same way that adding an entry to a union in a GraphQL schema shouldn't be seen as a breaking change. Like if it was A or B and now it's A or B or C, that should not be a breaking change, because your client should assume that that union may grow in future. And the same is true for these types. I don't see that as a breaking change. I think it would be unfortunate if tools were written in that way, and they probably are, but I don't think it's officially a breaking change.
Okay, I'm gonna give the first 4 this our intermediate solved with caveats answer. Okay, cool. We've gone through all of these. Now it's time to dive into solutions. Okay, I'll let champions describe each one.
Do you want to submit the edits that you've done already so we can then scroll through those whilst discussing?
Sure. Yeah, 1 second. Great, those are there.
Yeah, so type name discriminator field. This one is probably the most obvious solution because it's pretty kind of directly symmetric to the way that output unions work today. You provide a type name, or some other keyword that we decide, whether it's input type name or something else. That is the name of the input type that the union should be interpreted as. It's very explicit, it's very straightforward, it's nicely symmetric and kind of easy to understand for people who've already dealt with output unions. It tends to fall down in the cases where it requires a certain amount of transformation on the client to add the field. There was one other where it was not great. Can't remember. Yeah, there's a few kind of like actual behavioral issues where it's not quite perfect, but generally does pretty well, and is very straightforward, which is quite nice.
Yeah, it's pretty easy to explain how this is the polymorphism with input it's pretty easy to explain, or with output.
Yeah.
Do you remember the other cases where this kind of like behaves oddly?
If you scroll down, they are in the evaluation already. They were
okay.
So
type name can't match since input and output types are distinct.
Yeah.
So there is some transformation. You have to be able to say the output is a cat, but the input is cat input. So I need to update that as I pass this back to the server.
Yeah. It doesn't lend itself well to scalars any more than output unions do.
Mm-hmm.
It requires a tiny bit of metadata, so which was I think H. One additional field is required.
Yep.
And
oh,
there's no.
the other
Sorry. Go ahead.
The other one that I thought kind of where it falls down a little bit, which we talked about that actually kind of matters, is migrations. You can't just convert an existing field to polymorphic input type because the clients have to start sending the type name.
Yeah.
But you can introduce a concept of the default.
Right.
Yeah. Right. You can
So
do
if you don't provide type name, then you assume the type name is the default.
Yeah. Yeah. Obviously, it doesn't work well. So depending on which is actually interesting. This one was marked as a passier for I. Depending on the existing solution you're using to kind of fake input unions, it can be pretty easy to upgrade to, or it can be not. Like I think a lot of people are using fake tagged unions right now, which you can sort of upgrade to, but the inherent nesting in the current kind of fake tagged unions becomes redundant or useless or kind of garbage, which is not great. Overall, like I'm championing this one because I think it is probably actually our best option, but I think that's all I've got.
Yeah. Things I like about this one. I like that the syntax is super clear in the SDL. It matches them, I think, what most people's mental model will be of what an input union is. The discriminator, this is my favorite iteration of having a discriminator out of the group, is because it matches the discriminator that we use in output. So that input output isomorphism is super nice. I don't know if the default is the right one, but it sounds like there's space to explore variations that would allow this like discriminator being required breaking issue, or like I feel like there's a scenario in which a typical case could avoid the metadata. I don't know if default is the right one, but certainly it's an interesting one. But I feel like we should kind of leave that path open.
Just interrupt you for a moment, Lee. I think that there's effectively two places where you can put that default. You can put it on the union itself or on the field that uses it. I think the field that uses it is the better location because it allows for fewer unions to still be more compatible with the old system. And as you say, to allow that shortcut without needing the input type.
I'd agree. That said, I haven't seen a good proposal for what the syntax would look like for that default, which is, and additionally, nothing obvious comes to mind. So that would be a challenge probably to figure out how to syntactically include that in the query.
Yeah, and it kind of moves the like verbosity from the query to the schema. So you don't necessarily lose the verbosity, you just kind of move it.
And the discoverability is a little harder, right? If you're looking at the type definition itself, it doesn't contain all the information about how that type's going to behave.
That's true.
Yeah. Anyway.
Okay, we don't have to debate all of these in depth.
Yep.
There's some exploration
maybe it's
there for sure.
Yeah, let's keep moving. All right.
Cool. I'll talk about this one. So this one has a lot more variations that are possible within it. But the reason why I put my name behind this one is because it's the solution that I think enables a truly symmetrical client experience when it comes to taking a data structure from the output and like literally reusing it as is. given that certain things are done to model it so that that's possible. So it kind of sidesteps the type name altogether in both sides and introduces a new field that can act as the discriminator that can live in the output and the input. So it adds more kind of new concepts than the other solutions, because you have to figure out a way to specify what is the field that you want to use for the discriminator, and then what is the value that will map from like the value to the type, so to speak.
So to
It's
challenge
more
the
complicated for
benefit-
sure. What's that?
Sorry, to challenge the benefit that you've outlined there, I don't think you'll ever really in GraphQL be able to take an output type and return it as an input type, because we don't have, and we should not have, an asterisk operator. So we can't, if you add a new field to both the output type and the input type, you can't then necessarily feed that back in as the input without loss of data, because you'd have to update all of your previous queries to also query that field.
Yeah. Mm-hmm. Yeah, and I think there are some the level of complexity, and there's some kind of implicit things like that mean that this might not be the right solution. But it's like the stretch goal of trying as hard as possible to make it possible to enable the kind of, like I talked about earlier, the kind of Terraform style behaviors that could exist. So there's like, what do you use as the discriminator value? You know, you could use a string that you sort of hard wire to each type. You could use an enum that plays that role. It's basically trying to move away from using the type name itself as the discriminator to a custom value that people can define. So it's a bigger lift conceptually.
Could this be a superset? Could this be a superset of the previous proposal? Could the field that you specify be under type name?
Yeah, you could probably define it that, and then just hardwire that to be the type names. Yes.
Or
I
even
think that's
default
true.
that. So if your input union doesn't provide an explicit discriminator, it just uses type name. And then it all be kind of, yeah.
Mm-hmm. I like that thinking about it though, yeah.
There's something I'm realizing is that both of these two proposals actually are proposing adding multiple things. There's the input union bit that we're talking about, but they each kind of rely on an additional piece that we add to GraphQL that might be worth considering in isolation, maybe. But I think it's actually worthwhile to point them out. In the previous one, there's this idea that you could provide dunder type name as a field of an input object, which right now we don't allow you to do that, because why would you even bother doing that? But you know, maybe that's something that we actually want to just support. You know, if you want to say this is this type, sure, go ahead and tell us that. And this other one, there's this idea of a literal type. You know, like this double colon for namespacing an enum, or even just putting in a literal field here.
Mm-hmm.
That's pretty interesting. That's also not a thing that we've had in the past, but I can see why it would be important if that's your differentiator, your discriminator.
I believe there's an open issue on the spec repository requesting literal fields as well.
Mm-hmm. I wonder, how are they useful beyond this use case?
I'm not up to date on that particular issue.
Neither am I.
Probably are tied to this in the.
Oh, maybe we opened it as a output from this one. Anything of note in the evaluation?
Yeah, the migration. If the discriminator field is required, then yeah, you can't migrate you would have to introduce additionally like a default concept to here, to this as well. You can't do leaf types because of the discriminator field being required. I think it's not as straightforward as the basic under type name, but it is potentially more flexible.
Yeah, I like that the under type name is discriminator. I like how GraphQL-y that is. For creating an isomorphism between input and output. That's really nice. But for this one, I like how natural it feels. You know, like if you're trying to glue GraphQL together with some other system, like this idea of how much transformation on data will you need to perform. There's something kind of nice about your input being able to like accurately describe data that's coming from a separate source. And making it not rely on anything. Like there's nothing about this like variable blob that you have here that would give me the indication that GraphQL made make it look this way.
Right.
Which I view as a pretty strong pro from like a legibility and adoptability point of view.
And yeah, just to add to what you're saying there, Lee, if anyone's following the like Rails polymorphism style of thing, where you actually have a database table with a type column, then that type column people may already be exposing that through GraphQL as just one single type. But now with this proposal too, you'd actually be able to expose it as both a union in an output form potentially and an input form in a very symmetric way, which I think is very attractive.
Yeah. Okay, this next one I'm the champion for. So the idea here is that it's order-based discrimination. So similar SDL syntax to the ones above, but you don't explicitly need a discriminator. Although now that I'm thinking about it, the points that we made above about having some additions about like allowing under type name as a field in inputs, or even allowing literal types, I could see those like independent pieces still being added as a way to like this says nothing is required about having a discriminant. However, maybe we want to encourage people to have a discriminant. So if your two inputs are structurally unique, then a discriminant isn't necessary. Like you can just kind of interpret the difference between the two. But if the two shapes are overlap in some ambiguous way, then by default, then the order that they appear in the input union is the way in which you break that ambiguity. However, if there was some discriminant, then like a dunder type name or a literal field, then obviously that would allow the ambiguity to be resolved in its own right.
Yeah.
And my sense here is like kind of speaking to the idea of performance and it being O1 versus O of n. Obviously by default, this is going to be ON, but I would love to, like, if this is a path that we take, I'd love to introduce it alongside some tools for creating that discriminant in an input. I lean towards the dunder type name, but I'm totally open to the literal types as well. As like, if you do provide that, then it like automatically like run sophisticated services should like automatically upgrade that from an ON to an O1 operation.
Yes.
They should be able to look at it at like query persist time or at schema generation time, and see that every member of the input union has the same discriminant, and like be able to deduce that you should then fall back on the behaviors that we've seen in the previous proposals, without requiring that be the case in the scenario that the structures are different. Some of the nice things about this are, because it's purely about structure, that it doesn't matter what the shapes of each of these are, and in fact they could be scalars. So you could have string or objects. But if we go down to these, let's see. Yeah, subject to subtle dangerous behavior. I actually really like the idea of limiting it to you can only have one scalar as part of this list. While that's not strictly required based on the behavior described here, that it would use order-based discriminant. So if you had string or enum, string's just going to match first, like you're going to get a string. But because that is then later difficult to differentiate on the service side, without like wrapping those in some, like telling it like, hey, we matched this type and like here's the value. I think that might be a little too awkward on the service side. Limiting it to one scalar is probably the right thing to do to limit that particular case. Let's see, inhibiting schema evolution.
So the issue
Yes.
here would be, for example, if you added breed to cat, something that was previously detected as a dog would now be a cat.
Yeah.
So this is certainly, I think schema evolution, or like ambiguity in schema evolution, is the biggest downside to this proposal because of that. And I think this boils down to a difference between whether we want to think about these things as structural types versus nominal types. So far, because there aren't cases where we differentiate, they're kind of the same. It's isomorphic whether you want to think of them as nominal or structural. Now that we're in a scenario where we're like differentiating between multiple types that you could get, we want to be able to tell you what you have on your hands. And I realized in the course of kind of writing this up that I've been thinking about this as structural rather than nominal. So if you have two types that are structurally overlap, whether that is due to schema evolution or just based on the way that you wrote it in the first place, that sort of implies that you don't care. So you might think like, I have animal input, there's dog input or cat input, and maybe all of these things are optional fields. And actually, yeah, it is the case here. So name is the only case that's required in this particular example. What happens in the scenario that I say, you know, I have an animal and its name is, you know, Buster. Is it a dog or a cat? It's like, does it matter? Like, I haven't told you one way or the other. Like, it could be either a dog or a cat. We would match on one of these two, but if you only care about structural input and you've written your schema in a way that allows you that ambiguity, maybe you only care about the structural typing and you don't care. And if you did care, then you'd probably want something there that was an important way to differentiate between cat or dog. But certainly I think that if you only want to think about it this as nominal type, then that might break things. Like, you need to be able to differentiate, hey, I only got name, is this a dog or a cat? And that is a downfall of your schema design.
Yeah.
So I don't know if I would consider this fully a red X. I think that might be a matter of how we want to think about it, but I certainly admit that it's the most confusing aspect of this potential future.
I'm sympathetic to your theories there, though, that you just expressed, and the concept that one could add an additional explicit discriminator that would override the order-based stuff would mean that, well, not out of the box it would be solving it, but it would enable solving that problem.
Yeah, I kind of think that it's not acceptable to introduce this proposal as the solution for input unions without bringing that alongside a tool for creating a discriminant. My pitch here is just that I would like for that discriminant not to be required, but for that to be a tool for schema developers. Because if they have a scenario where the discriminant is useless, then I don't want to force them to have to use it. And if they have a scenario where that discriminant is vital, then I don't want to like keep that from them. And so I think like the strength of this proposal relative to the previous two is exactly that. Like, because this can represent scalars or objects, it makes it even more flexible to existing data coming from various sources. If we allow for Dunder type name, then like it creates a asymmetry between input and output.
Mhm.
And the adoptability argument, I think, is way clearer for this potential path than it was for the previous ones, because there's no additional metadata that you need necessarily. And so a field that previously only accepted cat input, you could now evolve to accept this animal input, and it would just, like, all existing clients would work. There's nothing new that's getting sent there. But of course, if you added a new required field to cat input, that would be its own breaking change. But that one's,
Would've been
an
anyway.
existing, and it would have been anyway. It's an existing breaking change that we can already
I
describe.
worry that if there are cases where a discriminant is like vital, and we make discriminants optional, then we are just letting either schema authors or client authors build foot guns.
Yep, that's fair.
I also have another comment on this. Without the discriminant, which is as it's proposed currently, if you were to feed a variable that was, say, a dog input type, and you specified that as a variable, but it only had a name, do we have a way of persisting the fact that you said it was a dog input via the variable?
Oh, that's interesting. So
You mean in the
variable,
implementation?
so you have a variable of type dog input, and then you're going to take that variable and flow it into a field that expects animal input. Is that right?
Exactly. Yeah, that's what I'm
Yeah.
saying. Yeah.
And so by the time it gets there, you should have already coerced it to dog input at variable resolution time, and then it's known that it's allowed that the dog input can flow to animal input. Persisting information, I think that's an interesting idea. I think one thing that we could consider doing as a implementation detail, right? Because from a client's point of view, I don't know, like, how do I know anything about how the client is interpreting my request? But from like a recommendation on how to build the services and what we would want to do on the reference implementation, I think if we considered allowing Dunder type name as a field on input objects, for example, then obviously that should flow all the way through to the consumer, the internal consumer of that information. The resolver should see that Dunder type name field. We could also consider if Dunder type name was not provided, we introduce it. So in a world before input unions, and you say, like, this field expects a dog input, and I provide you a JSON blob that has name, that what comes out the other side is a JSON blob that has name and Dunder type name dog input. And so on the internal side, you have this discriminant there already. And so existing cases could just kind of ignore the fact that this new field exists, but that would give them a tool. And maybe that's important for the previous ones as well, right? If you want to be able to say, like, okay, now that I've interpreted this information, how do I quickly, like, without having to re-implement the discriminant logic, how do I know how to interpret this input that you've given me? I'm like thinking about this number 2 one where, you could have a discriminator could be any field that you want it to be. If I'm a resolver function and I've gotten my input, now how do I know if it's a cat or a dog without repeating the logic of using, like, looking up what the discriminator field is and figuring it out? Hopefully we would not want to have to do that, right?
Right. I think this falls pretty squarely on implementation detail, because, like, when I think of the library I manage, Absinthe, you get a struct alongside the actual resolution raw data that's just, like, already parsed out all the stuff and translated it into, like, the type that exists in the schema and stuff. So
yeah. So if you're in a language that has well-typed structs that you can access at runtime, then you just say, like, hey, are you a cat input or a dog input? It's like, I'm a dog input. You're like, all right, cool. If you're in a dynamically typed environment like JavaScript, then you need to be able to look at that and figure it out, in which case we could.
Well, I mean, this language is dynamic too. But yeah, you would need to pass it some metadata expressing the discrimination process's result.
Yeah. Okay.
But yeah.
I think it now makes sense that sort of no matter which of the proposals we go with here, we're going to have to help answer that question of how do you take the answer to what was the final discriminated type,
Yeah.
and then provide that in a easy to access way. That's an implementation detail, but we should provide advice for how to do that.
Yeah.
And then hopefully that solves this
interestingly,
issue.
It's seeming
you brought
right
up,
now
Richard.
that the best solution to this problem is to take solutions 1, 2, and 3 and smush them together. I quite like that.
So this is really interesting. One,
Yeah.
I'm having a lot of fun right now. This is two, there was somebody who commented on one of these recently from like a programming languages background that was trying to express to us like basically these are all the same solution. And I'm kind of getting a sense in what way they meant that. Like we have a discriminant. It can be a variety of things. It can be a type name, a literal, or nothing. And then you have a way of resolving ambiguity. You can do it based on a default. You can do it based on order. You could do it based on one of the solutions we don't have a champion for is like structural uniqueness, whatever that might mean. So I'm kind of getting the sense that, yeah, that what you're saying, Benji, of like, these aren't exclusive in any way.
Yeah, the variance between them is actually pretty subtle. It's about like what's required or not required, and like how much control do we give to schema authors, how much control do we give to query authors, and how much of that control do we reserve either for our own future opportunity or to limit foot guns.
Yeah.
I could be temporary champion for 4.
To share where I stand at the moment, if I had to choose between any of these 3 that as they were proposed, I would go with number 1. And I think it would be maybe unfair to modify and rewrite these. Would it be better to maybe suggest a solution 6 that is a combination of these that explicitly handles this?
I agree. Yeah.
On the Dunder type name front, we would have to only specify that for fields that were unions. If we did it in general, it would be a breaking change against older GraphQL servers. So newer clients wouldn't necessarily be able to issue mutations or queries to older servers that don't support the double underscore type name field on inputs.
That's true. I might have to think really hard about whether that's something that's important or not.
I mean, we run into the same problem when we've added new fields to introspection.
Mm-hmm. Yeah. Yeah, that's it.
So sorry, go ahead.
What is a breaking change?
Yeah, we should answer that question. It sounds like that one we might be able to squeeze into. We could squeeze that into Yvonne's like 2-phase introspection algorithm. You know, you can imagine your first query to the introspection asks something about, like it provides a type name as an input and see if it fails.
Many clients don't do introspection though. They just have their fixed queries that they issue.
That's right.
So perhaps we're not quite done reviewing the solutions.
Yeah,
I think even though we don't have a champion, let's look at number 4. Was it?
Yes. Sorry, my intent was to discuss all of them and then kind of circle back and have a broader debate. But that was still a fun discussion. Yes. Structural uniqueness. So each type in the union must have a unique set of required field names. If I am understanding this one correctly, the idea here is, again, from the SDL point of view, same idea. You can express this input union. However, the idea of the discriminant is structure. So it becomes illegal to introduce a schema such that there exists an ambiguity. Mm-hmm. You need to be able to prove that any given pre-interpreted JSON will always be resolved to one particular type. and you can prove that from a structure point of view.
Mhm.
This I view as a variation of the rule number 3,
Yeah.
where you just like add additional constraints on how the schema must be designed.
Yeah, and I think I wrote most of this one up, and I have implemented the basic version of like resolving it and figuring out like what type is what, and it's pretty doable. The validation on the scheme side will be more interesting.
Honestly, that's my biggest worry about this one is doing that exhaustiveness check is kind of non-trivial. I'm sure we can figure out the logic for it, but that's not a super easy thing to do. I'm curious, as you implemented the prototype, were you able to come up with a solution that wasn't ON, or does it just have to be ON?
It's ON.
Okay.
I think you could probably make it O1 in expectation with a good hashing and preparation stuff at schema build time, but my objection to this one is more along the lines of like there are nominal type cases where there are not unique sets of required fields, and so you'd either have to introduce like a fake input field or just make the discriminator required as an input field.
So concerned that the actual real life schemas that will result from this will include awkward fields that they otherwise would not have added purely to get around this uniqueness requirement.
Yeah.
It also
There's that.
potentially inhibits the evolution of them. If you wanted to say that the dog input breed is no longer required, you couldn't do that because it could no longer be contained in the input union, even if you're using it on its own somewhere else.
There's also some, like, the set of data structures you can model is not the full set, right? You're putting some artificial limit on what could actually be modeled. So, and when you're going to run into that is kind of just like pretty hard to predict.
Yeah.
Somebody's going to not have ever read the details of the spec, and then all of a sudden, like, you add this new field that you're going to implement it, and like the thing yells at you, and it's like, oh, you just can't do that anymore, and you'll have to like kind of hack around it with what we're talking about of like some fake field that's meaningless.
Yeah, and you can't make the fake field required because that would be a breaking change to existing schema.
Yeah,
so
it
sounds like
the new thing you're adding.
Main objection to this one is that you can accidentally design yourself into a corner and then not know how to evolve from there without breaking.
Yeah, and you'll have, we could also, in the same way as all these others, like enable people to use the under type name to be really explicit, but this, since it's at the schema validation phase, like you couldn't even create the schema to let people explicitly provide the type.
Yeah, I mean, same argument about breaking change compatibility, right? Like if you evolve the schema in a way that says, okay, you've now broken the structural uniqueness guarantee, therefore all clients are required to provide type name to disambiguate. The previous clients have not been, so you're kind of like right back where you started in terms of painting yourself into a breaking corner. Interesting, looking at criteria E, ambiguous types have to be or unable to be discriminated. Actually, like if you interpret this as proposed, that like each shape must be unique, that kind of leads you to a conclusion that you could only have one scalar type, right? Because a custom scalar, who knows what it's going to look like, and if you had string and ID, it's like those are structurally have structural overlap, so that would just be not allowed. So coming back to our previous discussion of these all being variations of the same thing, kind of interesting that this requires a limitation on the leaf type that is actually a proposal that we had to break or to fix a complaint about this criteria. So still valuable for that conclusion.
Yeah.
Maybe safe to put this one at the bottom of our list, or maybe even go as far as saying we're rejecting it based on, one, not having a champion, but two, this idea that in an attempt to limit foot guns on schema design, we've actually created a bigger foot gun in schema design.
Yeah, I think it's fair to say it's complex, it's dangerous.
Benefits are not obvious.
It would be a really good outcome of this meeting to have crossed one of them off.
Yeah, I agree. There's actually, if we're gonna end up proposing a solution 6, that's like an amalgam of some of these. What's actually interesting is that the idea of structural uniqueness is actually maybe good design. The requirement of it is dangerous.
Right.
But you could imagine, like, if we're talking about this criteria or this proposal 3 alongside some of these other ones, you could imagine criteria 3 along criteria 4 is in essence proposal 3 alongside proposal 4 is in essence proposal 4. But that as like a design suggestion on how to make this a little bit more clear is not necessarily a bad thing.
Yeah.
But requiring it is.
I think,
Okay. Oh, sorry, Evan, go ahead.
yeah, I think what we're coming to just right before we get to tagged unions on one of is like, we want it to kind of probably look a lot like solution 1, but with a kind of amalgam algorithm of like what to do when the discriminant isn't provided. Anyway,
yep,
that's going to be the end of meeting discussion.
Sounds good. I'll let you talk through this one, Benji.
Yeah, this is quite simple. So basically, if you've got an input type already that has all nullable fields, where each field can have a value of any type, and these types could potentially be the same as well. We've got cat with cat input and dog with dog input, but we could have like dog1 with dog input and dog2 with dog input also potentially. That's potentially useful, for example, if you want to say you've got an email address, which is a string, or a username, which is also a string. So you can then tag this one of, and effectively the idea is this gentleman's agreement that we have, many people who are implementing this already just have in their resolver, if not exactly one of these things is set, then throw an error, basically. So you could then introduce this, and then the client actually knows that exactly one of these is required. It's effectively just a small enhancement. I think one of my main issues with this is, and it's already happened, people saying, well, why don't we just have this on outputs as well instead of like the existing unions and interfaces? And I think though we could do that, we absolutely could, it doesn't give you the same benefits that say a interface does, where you can query the same fields. So I don't think it should necessarily be expanded to outputs, or at least I haven't thought about it in depth. I think it would complicate things there, and there is that kind of symmetry thing. One potential solution to that is just don't use a directive, just call it input union. And literally just the way we frame it may be sufficient for that. In terms of actually the changes required for this, they are so tiny. It's like one extra field in introspection, and that's basically it. So it's fully backwards compatible. You can add it on top of your existing schemas. It's very simple, quite flexible, but also it's not solving exactly the thing that we've set up with input union. I think it's effectively it's its own thing that happens to solve the input union thing, but it also solves the other problems, such as more the finder style of thing. So it's interesting.
interesting to think about what this means for symmetry with output types. Fun story, when I was originally proposing unions and interfaces as ways to do polymorphism with output, Nick Strock was actually the one who pitched the idea of like just cutting all that stuff and only doing like structural unions. And the shape wasn't quite as clean because we hadn't quite landed on directives yet at the time. But it was basically this idea of, you have a output object. It's just a plain object like everyone else, but it's guaranteed to only ever fulfill one field. So all fields will be null except one. And then that we can just guarantee that at a type level. And actually the proposal was that we wouldn't even send down the fields in the type that were null. So you wouldn't get like A is null and B is null and C is null and D is some big object and then E is null. You would just get back D is this big object. And that would be like a new thing. I think we eventually like looked at that and thought there's too much stuff there that was weird, and defining them was also a little bit weird, and so we backed away. But it's pretty curious that the idea continues to pop up, and I wonder if we decide to go this route and only this route, it might actually give credence to allowing something like that on the output side. I do think that there is some argument for input and output having a similar shape, in which case, like, maybe that's an argument for not doing this. But if we decide to do this in addition to doing something else, like we give you two tools that you can use, which we can discuss whether that's a good idea or not. But if we did, then we might again also want to say like, hey, you can do unions for outputs, but here's another tool that you have, and it makes this guarantee on the output side.
Yes, it would allow us on the output side to do unions with scalars as well, which is quite valuable. It would definitely not replace interfaces. That's the main thing I'm saying. Like, interfaces are very powerful, and I don't think you can do interface stuff in this way. But for unions, I think it solves the problem of unions both on input and output well, but we already have output unions.
Mm-hmm.
Yeah, I've said this before, but I'm a fan of this, but not exclusively. I think this is powerful in its own right. And I hadn't thought too much about it on the output side, but it is kind of interesting if you, if a schema has already gone the route of using a tagged union to solve these kinds of problems, there's the decision that they've made whether they model it on the query on the output side as like a similar type tagged union or an interface. And sometimes using the tagged union on the input side might mean like forgoing interfaces or unions on the output side and just being really literal explicit with the thing. So it is opening up a possibility, like if you pick this tagged union and forego interfaces or unions, you do solve the problem of being able to take the data structure from the output and like just reuse it on the input with no transformations. But you have to forego interfaces and unions universally on both sides.
Or you can just use it to model unions on both sides, and then maybe an input interface is a different solution. So another comment, I think one of the things that's really missing from making this super powerful would be being able to apply this to arguments. And I've talked with Lee before about how input objects and arguments are basically the same thing, but they're not the same thing, which makes them kind of awkward to deal with. And for this finder scenario where you're finding by ID or username or email, it would be very useful to be able to just say, to have that as an argument rather than having it as one level nested in an input object. But I'm not sure if there's a way, I haven't figured out a way to solve that in quite as clean a manner as this currently. Like, I've already written up the RFC, the spec edits for this, and they are very small.
So you're basically saying like tag the field which has arguments itself as a one of. and then that would apply to the arguments.
Yeah, I'm not really sure. And also that potentially stops you from adding an extra argument that isn't part of the one of later, which
Right.
may or may not be appropriate. So my thoughts around that are fuzzy, but also there's a lot of these X by Y fields where they could be expressed as arguments, or maybe already are, where you could use a one-of potentially, but I don't know how to do that for arguments. I only know how to do it for input types.
Yeah, I like there definitely is a very strong parallel between arguments and input objects. At one point, I tried to put them together and make them one thing. The tricky part is that input objects have a name and then they're referenced by name. And while the shape of arguments are the same, they're anonymous, or rather they're tied to exactly that one field. And I couldn't figure out a way to do that in a way that wasn't broken. But syntactically, they're actually the same.
Yeah.
And
Yeah, totally.
so I kind of like the argument that if we introduce one of, we should think about it not just as here is a thing that you can use on an input object, but here is a new directive. It's a tool. And then we should think, what are all the places where it makes sense to use that tool?
Yeah.
And so clearly it makes sense here. It could also make sense applied to a field to then apply to its arguments in the same way that it would apply to a named input object. Maybe it also applies in output scenarios as
Yeah. Well,
I think especially if we end up introducing this alongside a input union type, then there's a really strong case for doing something like that on the output side too.
so I want to go back to something that Benji said earlier, which is that using this as a directive called one of is really, an arbitrary syntactic choice at this point. You could equally design this particular behavior and still just have it called input union and be a new SDL keyword called input union, or even just make it a new
Certainly.
option on the existing union keyword and just allow existing unions to be tagged. And that has all of the same properties as this, but applies supernaturally also to output unions because that's what they already are. We just let them be tagged.
Oh, that's interesting. So whether unions are unions, sometimes they are tagged and sometimes they are not. There are two flavors of a union, tagged and untagged.
Yeah. And a tag union.
Maybe add tagged union concept, and that's the type that isn't allowed in both input and out, or not the same, but that's the thing that is able to mirror in both sides.
Yeah, tagged unions are identical in between input and output, and they look exactly like existing unions, but tagged in the way that this one of animal input is tagged.
Are you saying identical as in you can use the exact type in both places? To break
whether the SDL distinguishes between union and input union, or is just implied based on whether its members are input types or not, is kind of a separate question. But the tagging of the relevant part.
That's an interesting idea.
I don't know if it's any good because I only just came up with it.
I will say I do like being a directive means that it can apply, being able to create some parallelism, continue the parallelism between field arguments and input unions, just input objects. That's interesting to me. I haven't fully thought through the implications, but I kind of like that. And moving it to a keyword limits that. Maybe that's fine. This is a very interesting idea, though, to suggest that there are two potential forms. We'd have to think about what that meant for introspection in addition to SDL and usage. But very fascinating idea. We should explore it.
So we've made it through all the things, I think. Is that correct?
Yeah,
Or-
that's all fine.
Do we want to take a quick bio / get some water break? Come back in a few minutes.
Sounds good to me.
Yeah.
Yeah, sounds good.
Let's regroup at a minute or so past 11.
Yeah. Cool.
Okay. Time zones.
Or, yeah.
Or yeah,
Whatever
a minute
time
or-
it is.
Past the hour, I should say. Past the hour.
And just FYI that I'm gonna have to head out in about half an hour. So, but that's fine. I got another 30 minutes and change.
Cool.
Sounds good.
Okay, see you soon.
Be shortly. So my little 3-year-old's downstairs on a Zoom meeting as well, doing circle time with the preschool.
That's adorable.
Yeah. Oh, and I was talking to people over here. It's super cute, a little grid of like 16 little kids just talking all at the same time. One teacher in the middle trying to like corral them.
Oh man, mine is not quite 2, so not quite at preschool level yet.
Mm-hmm.
But that sounds really, really funny.
It is.
I am back. You feel free to carry on. I'm just wolfing down my dinner.
Oh, very nice. Let me see if I can. Oh, new share. Maybe that's the right way to do this. I just in the last minute or so. Let's see. Did that work? Can y'all see my text editor?
Mhm.
All right, cool. I realized that if part of how we want to think about this is an adoption path, then if you're previously using a tagged union with this sort of agreement that you're only going to provide one of them, and you migrate then to any of the first 4 proposals that look like a union of input objects, that it's super like explosive and disruptive to your schema. Like you basically now need a nominal type that describes each of the options in your union, this like bottom half.
Yeah, if you want to keep these queries working the same.
Yeah, if you wanted to migrate from a implicitly tagged union to a explicitly tagged union.
Yeah, well, I mean, in that case, like, what is the point of even migrating?
Or I guess this is wrong. This is this should be this, right? Yeah, exactly. I mean, that's kind of my point, right? Like if a bunch of folks out there really want input unions and our answer is like we're working on it from the spec point of view, but like meanwhile we think input object as a tagged union is like an acceptable way to proceed, then if we come out of this with this proposal and we say like, all right, you've been doing the kind of like reasonable intermediate solution, now here's the right long-term solution, uptake from those 2 solutions is really awkward.
I mean, yeah, a lot of this is solvable with good server-side tooling in terms of like being able to generate all of those option types, and also providing an upgrade path for clients by like duplicating all of the fields from cat onto cat option.
Mm-hmm.
So
that, but like, yeah, it's not ideal for sure.
I mean, for the services that do this in our ecosystem, like if you've used tagged union, that's just the end of it. Like you're always at a tagged union. I would recommend to people like new APIs, yeah, like pick up input union from out of the gate. But if you're already a tagged union, like you're already doing polymorphism, it's just clunky. But I wouldn't recommend migrate.
I guess what I'm saying is that this gives me even more confidence that some, either including a one-of directive or supporting a tagged form of an input union, could be really valuable as like as an adoption path for this pattern, whether it's a pattern that people explicitly like and they want to use this like structurally tagged union, or whether they were just previously using it and they want to continue to use it, but they want to layer on top of that additional guarantees.
Yeah.
Another
I think
thought
that makes a lot of sense to me. It's like, hey, you were using tagged union. Here is a directive that can make your requirement explicit.
Yeah. This might be a little too crazy, but another thought is, should we support anonymous types in inputs?
How would that work for like sticking it in a variable?
Yeah, a variable. I don't know if we want to allow variables to be anonymous types or not, but in a scenario where it's clearly going to show up once and only once, you know, like, is this, like, this form here is exactly equivalent. Here, let me just get rid of this one.
Yeah.
So
Yeah.
I think with the anonymous types, and anonymous types is another thing that's been requested quite a few times on the GraphQL spec spec repo. I think the issue is it allows for the like explosion of complexity. Like that dog there could well be dog colon and then another embedded type, which then could have another embedded anonymous type. It also stops us from doing things like dunder type name, right? Because we don't have a type name for it. So we can't use the type name as a discriminator anymore.
Well,
though that
just
may not be important because you only do it at the root.
right. It would like, yeah, you would basically say, if we decided to allow dunder type name, then it would only be allowed to provide dunder type name to a named type, not to an anonymous type. Anonymous type, that would be a legal field. Right now we don't allow it at all, so there's no change. But if we were to introduce both, then that's how we'd probably resolve too.
I mean, what you've got on lines 25 to 27 right now is just an alternative syntax for one of, right?
That's exactly, yep, exactly.
Yeah, right.
That I'm thinking about, like, in a scenario where, so like back to this discussion about one off doesn't necessarily need to be a directive. Maybe it's just an alternate form of the input union SDL syntax itself. And in that scenario, you know, what is it? Do we only support one of? Do we support both? And like versus this like idea of a tagged versus untagged union, having two forms. This, I'm saying this knowing that that might be too bold. Like introducing anonymous input types might be a little too much, too far to go. But there's something nice about the idea that you know, both like here's the tagged and untagged version of this, and they're the same. There's nothing, right? This just happens to have this like anonymous type wrapper, and it gives you an adoption path from both previous methods. Like if you had something that was only accepting one type and now you want to add a second type, you would do this form. Or maybe if you were designing a schema from day one, you might do this form, or this is also totally fine. Or you would use this as ways to model data that's coming from wherever it is that you know you want to model data in the form that you're getting it, and so this is the way that you decide that you want to do that.
Okay.
So I see a few potential issues with this, which I'm sure you see as well. One is people might expect to be able to put line 26 and line 31 in the same input union, which wouldn't necessarily be valid. Yeah, like that. Another issue is, and this is the one I'm more worried about, if we add anonymous types here, people are going to want them everywhere.
Yep. That's the reason why I'm saying maybe this goes too far, because certainly we would want to think about anonymous types in general and broadly what kind of things that would break.
And I think given I think the one of is really explicit, and the fact that it's used in other type systems means that it's a concept that exists elsewhere, that you have your priors and you come to it and you're like, oh, I get what that is because I've seen it in XYZ. Whereas this like subtle syntax to it's not even explicitly saying tagged union. It's kind of a little, you have to interpret.
Yeah. There's another way to think about this I'm just exploring this idea of like what happens when we merge all 5 of these proposals together in some way. Is like allowing these 2 different forms. You can imagine this also applying to output unions, right? So
Yes.
um,
Yeah,
in
and
a
that's
scenario
what
where,
proposal. That's what I had kind of was spitballing, was exactly what you've got, 31 to 47 there.
yeah,
If we zoom way back
Should we
into,
call it tag union?
I don't think that this really counts as rolling 1 through 5 altogether. I think what we've kind of ended up at is that there are two broad paths forward. There is the tagged union path forward, and there is the discriminator path forward.
Right.
And that both of those have like a bunch of options, 1 to 4, and various combinations for discriminator, and then one of versus like explicitly tagged union types versus all of these other things for tagged. And we could plausibly introduce both, although, you know, off the top of my head, that feels like sufficient redundancy that it's probably a bad idea. For the working group and for this group, this subgroup, my question is, do we want to proceed depth first or breadth first?
what do you mean depth first or breadth first?
Do we want to pick between discriminator and tagged union and then figure out exactly the best way to accomplish that thing? Or do we want to figure out the best version of tagged unions and the best version of discriminated unions and then make them fight?
So I tend to think there's enough stuff to figure out within the discriminator universe that it's worth diving into that. And I also tend to think that the tagged union in the form of one of could be its own proposal that we move forward aside from input, like the discussion of input union.
Not, and maybe this, because I've heard of this a couple of times now, but I don't actually know what that's referring to. What use cases does one of solve that are not specifically union use cases? Like
it's just a general tool that you can use for your inputs.
I'm fine.
So it can be used for unions where the same like the tagging is important. So for example, take Medium. Have you used Medium as an editor? Anyway, in Medium as an editor, you have a series of different blocks, okay, and each block has a type. So it might be a title or a subtitle or the body text or an image or an embed of a video or whatever. So you can imagine that that is effectively a union of blocks, right? And if you were to represent those as a one of, then you might well do it so that the title is a title colon and then just the text, and the subtitle is subtitle colon and then just the text. Those are both just strings. Whereas you might have video, which is then going to be an object which has the URL and a caption or something like that. So there are situations like that where actually it's useful without needing you to add extra complex objects when you literally don't need them because you just want the text string.
I think what we're doing here is we're kind of rehashing this question of whether we should have both or not. I'd love for us to decide whether we should have both or not last rather than first. I think if we kind of move forward with one of independently of the rest of this, it just kind of complicates the whole thing. Like, why are we talking about discriminated unions when now we've got a tool for unions? Like, we can shut this whole process down. We should be super clear with our kind of combined suggestion as to whether there should be one way to do it, or whether there should be 2 ways to do it, or whether they're like 2 variants of one way to do it. I think these are all kind of views on the same problem.
All right, so that means probably we should talk in depth a little bit more about the differences between the earlier proposals.
Yeah, let's, Evan, to your question, let's go depth first. We talked about adding this like criteria or proposal 6 that's like some kind of amalgam of some of the first 4. So maybe we want to hash that out.
Yeah, I almost want to like start a new thing, which is like, here is kind of our best best amalgam version of tagged unions and our best amalgam version of discriminated unions.
Yeah.
Well, there's one major difference amongst the discrimination techniques. There's the type name that references like literally the type name, and then I get the words. And then there's literal. Sorry, that's framing of the words. But basically, type name and literal values.
Yeah, but I feel like
those are pretty different.
If we're within the world of discriminated unions, type name versus literal values is a much easier question to come to consensus on than if we're also trying to compare it to one of.
Yeah.
Mhm.
Let's just stay in the world of discriminated unions for a little while.
And
So we
then
have this
there's
question.
no discriminator possibility.
Yeah.
Well, there's
Structure, order, and none.
Yeah, this is how I'm kind of interpreting this. I can make this. Now it's literally how they're set up, 1, 2, 3, 4. So they're all just about this question of how do we discriminate?
Yep.
Whether we discriminate by type name, by a literal value, by the order that they're defined, or by structure.
Yeah.
It sounds like now our option 6 is any of the above.
Yeah, well, I mean, you can do any kind of combination of like this one optionally, and then this one optionally, and then this one is required. You can kind of do any combinatorically valid combination there.
Mhm.
I think if you change the order of the last two, then that would effectively be the order you'd evaluate it in, right? If you specify a type name, then you are concretely saying it's that. Otherwise, if you've got a literal value, then that is going to, assuming that it is a unique union of those literal values, that is almost as good as type name. Then you do structure because it needs to be valid, and failing that. Well, is order defined and structure are kind of the same though, right?
I mean, order defined is one way.
The first one that fits the structure.
No. Well,
Well, I mean, if the structure is unique, then you could sort by random, evaluate, and get the same result. But if the structure is not guaranteed to be unique, then you could sort by random and get a different result.
Yeah, so it's an optimization of the order defined where the structure is unique.
Yes. Yeah.
So there's a default possibility in this here too,
yeah.
as a fallback.
I would sidebar, I would say literal values are not kind of part of the structure, because structure is very much about the shape of the schema, and literal values are very much about the actual value in the input. And those are separate worlds.
Yeah, they are different. My thought was like, I think it's just a different way to interpret that. Like if you say I have a field A that's always the string A, and then I have a field A that's always the string B, you could kind of look at that as structure, because you know that it's a literal part of the structure.
Mhm.
I accept that that's kind of a weird interpretation though.
Yeah, that's right. Anyway.
So the way I see it at the moment is Lee brought up the question earlier of, are these structural or are these nominative? We're basically saying, yeah, let's have both. And
Nominative versus set.
Say again?
Nominal types are like a strict superset of structural types, in that they can represent all of the same things and more. So I think, I mean, my intuition here is that we need nominal types and not just structural types. And I don't know if everybody agrees with that.
So my preference would be for nominal types, but they are larger, like they contain more context. So they are literally bigger. You have to write more stuff.
I guess the question here is, should we require these to be, knowing that nominal types are a superset or subset? Knowing that nominal types are a subset of structural types, should we require that these are nominal types, or should we just provide you the tools? Like it seems like we don't want a scenario where you're beholden to structural types only, and you have no way to represent nominal types if nominal types is what you want.
Mhm.
So we have to at least provide the ability to suggest, or maybe not have to, but it sounds like the consensus is that we want. If people want the ability to express nominal types, we should give them that ability. But we should also think about the other way around. So if someone wants structural types, should we say, no, sorry, nominal types are required, you must supply the nominal type? Or should we also say, okay, no, that's also a tool in your toolkit? Should you be able to choose between the two, or should we enforce one or the other?
That's a good question.
My opinion is just enforce nominal.
I'd like to be able to choose between the two. I'd like to give schema authors the ability.
I lean to enforcing nominal as well, but I don't feel well argued on that. Well grounded in that. I just like, it seems with very little evidence that the cost of providing a name when all you really want is structural is pretty low, and the benefit in avoided foot guns is pretty strong.
The cost
Also
is
like schema evolution as well, right? You don't even have to consider the complexities of evolving your schema in such a way that you don't break the structural discrimination.
correct. Yeah, it's a trade-off between the complexity of schema evolution versus the adoptability, knowing that right now explicitly providing nominal type doesn't exist. So that's a new thing, which means all existing queries do not provide this. So it is figuring out how to adopt this will be a challenge. You will not be able to take any existing field and turn it into an input union if nominal typing is required. If nominal typing is optional, then it provides adoptability for existing use cases.
Depends what you consider default, because default provides some adoptability, but isn't really structural, I don't think.
Yeah.
Would we consider this literal value to be like a nominal or structural type of thing?
Nominal. It's just a different form of nominal from under type name.
So it's a name, but it's not the type name, but it one-to-one maps to the type name.
Yeah, it's just what your name is. Well, it's I don't know. It's like a little bit of an in-between land, right? Because the name of the type is the name of the type, and your literal value discriminator might not be the name of the type.
Right.
So you might get back a dog input, but the thing that you provided was some enum field called dog.
Yeah, all of these are isomorphic if you look.
Correct. So it sounds like if we were to decide that nominal typing was required, then we've circled all the way back to proposal 1 as it was proposed. If we
with modifications perhaps, but largely as proposed.
Would there be a possibility for a combination of 1 and 2 in that if you want to, you can explicitly set and control the discriminator yourself, but if you don't care, it's type name?
My feeling is that, like, looking at 2 as an extension of 1, the value trade-off becomes different in that, like, the marginal value versus the marginal complexity is no longer worth it. But
I mean, for me, the marginal value is extremely high. Like, not having to have a map from output to input type and being able to control that and have that the literal exact same value in both places is a huge win. It means, like, you don't have the clients don't have to have that mapping, which is not, there's no way to express that explicitly. And they don't have to transform anything, which is a benefit both in the single, like, flat case and a real benefit in the nested case.
I also think we could probably deal with that as a separate question as well, of, like, if we agree on ship 1 and then come back to 2 as an extension to 1. That kind of comes in its own RFC after the first version is shipped.
One thought for option 2. Option 2 has this directive discriminator that describes which field is the discriminator. Is that strictly necessary?
No, it could that was just a quick way of putting it into the SDL, but, like, if we're building it in, we can give it a syntax that's not a discriminator. Like if we
Yeah.
craft the input union syntax to take that in some form in,
Or I'm thinking like
definitely doesn't have to be a
your service should be able to deduce this discriminator, right? Like if it sees every single input in the union has a field called species, they all happen to be literal types. Now I know that that is a discriminated union based on the species field.
So the requirement would be like when the schema is being compiled, there must be a discriminator, or like every member must have a matching literal type. Or literal field.
Maybe. I as you
Something like that.
describe it, that's a good variation of two. I'm thinking of like if we want to consider an amalgam proposal that's like some combination of the first four. Maybe, so here I'll just start typing something out live. But the idea is, so from first point is no immediate requirements for uniqueness.
Mhm.
And at a minimum, an order-based discriminant can be used. So this is basically is proposal 3. But then in addition to this, we say type name may be provided for any input union or object.
Mhm.
And this provides a discriminant. So this is saying type name is not required, but it's you may provide it. So it's a bit of a in the middle between them. So right now you can't provide that at all for input objects. This would say you're now allowed to provide under type name as a field for anything that expects an input object. And then like if that field becomes an input union at any point, or if it already is an input union, then that's just definitely your discriminant. And then in addition to this, introduce literal types, and these can become a discriminant. I'm realizing I'm just type aheading the wrong word. So this doesn't necessarily guarantee you O of 1, because you could have a scenario where you have a cat input, species cat, dog input, species dog, and then something else that doesn't provide species. And so if species is provided, then you know for sure that it's one of those things. And if it's not, then it goes to something else. And then the question of whether this is O of 1 versus O of n, kind of to Evan's point from much earlier, ends up being an implementation detail, and services can decide how complicated they want to get with that. If they want to do some wild hashing technique to be super sophisticated, or if they just want to like, oh, look, I see you have a single field. I'm going to guarantee that.
What about if the literal type itself is not unique? So for example, you've got cat, which has type cat, and dog with type dog, and then you've got like wolf, which is maybe also type dog, for example, or vice versa.
Then it falls back to this: at a minimum, the order-based discriminant is used.
Isn't that a designation that happens in the schema itself that could be a schema validation error?
That's what I'm trying to discern, because that would also get rid of the possibility of the literal type not being present on one of the things in the union, for example.
So this is an interesting question about this, like this third type, or this third point here. You know, in the same way that you can't have two types with the same name, should you be able to have two separate types that both supply this?
Right.
Maybe regardless of whether they're used in a union.
I mean, yeah, I think you absolutely should be able to. Like, you can have two dogs that have different breeds, for example, and even the breeds themselves may well be literal types.
I guess what this is pointing at is that the customizable discriminators open up a much more complex like set of potential to map from the input to the union. There could be like 3 fields that are taken into consideration, and then like the combination of this value, and this value means this transforms into this type. So the function of like this data structure, the input structure to the type that it needs to be, isn't necessarily like just one value to one value. It could be like some set to the end of value.
Ultimately,
that could be very complicated.
Yeah, you can construct like any Turing complete algorithm that looks at the actual input and decides what type it is based on any number of combinatorial factors there.
And expressing that in a way that sure, you could write a server that would do that, and the logic would be pretty straightforward, but not in the client. Like expressing that in the static introspection is.
Well, yeah, expressing that in the schema becomes a question of like, is our schema Turing language Turing complete, which it's not and shouldn't be. So,
right.
We have to cut out some use cases as complicated to support in a static schema language.
Yeah, so if, for example, if this is allowed, and you could look at this and eventually you get to the point where schema validation is going to get too complex to be able to differentiate between these, and you just fall back on the idea that we're going to try A and see if it matches, and if it doesn't, we're going to try B, and you just kind of like know based on, eventually you should be able to get a shape that's different. And in a scenario where they overlap, then the first one is going to get chosen.
Yeah, or
so
the client gives up figuring out what the server is doing and just provides an explicit discriminant at that point.
Right. So yeah, you just like do that and then note. Yeah, this is kind of, I think, the final conclusion of like this combined proposal is if the bottom, like if you can't guarantee uniqueness, then you just do them in order. And then the algorithm for resolving the input union is, as specified, you check to see if the input is valid for each input type in order until you find one that it's such that it is, and then that's the type that you use. But that's not the ideal algorithm. That's just like the algorithm that must be upheld. And then
contract
clients are services are suggested to do better in the scenarios where they can. So the simplest possible implementation is to do that, but services are encouraged that, like, if they see type name in the input, then they should like quickly jump to that one and check it, and don't bother checking the other ones. Do we need to write it in the algorithm? Probably not, but if it's not required but it's allowed, then that would be a non-normative note.
The question, I guess, is,
yeah, I was going to say, you think in the spec we would only write up that main algorithm, and then the rest would be a, as you say, a non-normative note to just say there are better ways, potentially do those, and just hope for the best.
I mean, I don't know if we want to ignore it. If
well,
provide the type name and the server says, no, I'm just going to like try them in order and choose one that's not the type name you provided because, that's what my algorithm did, like, that feels bad.
Well, it can't, right? So when I say normative, what I mean is like it either is or isn't GraphQL based on following some behavior. You can prove that these are isomorphic, that the algorithm to try them all in order, given a type name field is provided, and you check the type name field as part of the algorithm to know if it's a match, has identical outcomes to an algorithm where you first look for that field. Like that's provably only a runtime optimization and not a behavioral change.
I read try them in order as only looking at structure, not looking at the values provided.
Oh, yeah, super important distinction. If type name is provided for any input object,
It only matches that input object.
it must match the type name.
Yeah. Okay.
Yeah,
It must only, I think that only is actually important there. It can't match anything else as well.
yep. That should be guaranteed by schema validation. Yeah. So the providing the type name is will definitionally mean that one and only one potential type could match.
Yeah.
So trying them all in order is just like a pretty inefficient way to ultimately get there.
Yeah.
So I don't know from a normative point of view that we need to explicitly state that, like, if you get the type name, then you have to do this other thing, because the
Yeah.
outcomes of the algorithms are isomorphic. But we should, that's what I mean by non-normative note in that case, is like anytime where there's pretty obvious opportunities for optimization, it's helpful to specify them in the spec, so that implementers can spot those and take advantage.
Yeah.
So for the literal types, it does seem like a schema level restriction that there must be a one-to-one mapping from the literal value to one type would contain the sort of unbounded complexity of the alternative that we're kind of expressing. Does that?
You mean that this thing here should not be allowed?
Right. And that kind of pushes a little of the input union requirements into the input type itself. Like if you participate in an input union, then something about the literal values applies, like this rule about the literal values.
Would we require that across all input types, or just those that appear in the same union? Probably only that appear in the same union, right? Like you could have a scenario where, I don't know, maybe you have a set of input types for mutations versus a set of input types for creations that are different, and they both want to express that, like, I'm a dog in this case, or I'm a cat in that case.
I actually have to.
Right.
But I think this was great so far.
Thanks, Evan. Yeah, we'll write up the rest outcomes of all this.
Great, thank you. And I'll see you probably is next week for the actual working group meeting, right?
Yeah.
Cool. See you then.
All right, take care. So yeah, I think you could totally imagine the same input, there being like an update and a create structure, input structure for the same concept, and they would both have the same literal value because they reference the same thing that's going to come back in the output.
Right.
So yeah, it would raise the complexity there is like you would have to ensure that any particular input union, its members literal values were unique.
What about this counter proposal or this counter example where, you know, maybe you have a collection of dogs and cats, their breeds are all unique, but their species are not. And because they same input object appear in multiple places, you might want to, you know, specify both.
Yeah, I mean, I guess in that situation, you're sort of putting there's this blend between like just descriptive fields and then a field that's intent is to be a discriminator.
Yeah.
So you could format them as like, you blend them together. So you're using the literal value contains the information to express both fields. I guess what I'm kind of like, wolfhound dog, wolfhound cat all together in one field. So there's it seems like there's something about this particular field that's different than every other kind of field because its goal is explicitly just to be the discriminator.
Right.
And so when you have a discriminator field, it has to be unique in the input union that it participates in. But that's, I mean, adding the literal values, I guess, is what is raising these complexities. Because you're leveraging the field, which formerly it was just like it contains a value according to a type, and now it's like carrying this other purpose.
Right.
And it's not as straightforward as the type name, which is like just really literally the thing you're trying to match.
Another potential issue with this is it puts the decision of whether this matters in the hands of the client and not the server. So the choice of structural or nominal, it might be that the server thinks that actually these things are concretely different things. If we're doing it purely structurally, does that mean that the client they can choose to not specify the type name and then it just uses order-based discrimination, which may then not be as explicit as the server would want? Does that then mean the server needs to add, for example, non-nullable fields such as in solution 4, which we've already suggested is not necessarily the best way of doing it?
Yeah, that's an interesting question. This idea that like even if you allow type name to be provided, you can't require type name to be provided based on how we have things set up in the moment. And if the server wants to enforce more, I mean, spitballing, but directive that says type name required or like discriminant required or discriminator field type name or something, like maybe we can even borrow this discriminator field as an optional tool for schema designers. I don't know if that's the right thing, but
so what the value in for me in the literal is enabling this to function without having to do the mapping from the output to the input type. But if say we drop the concept of the literal, because it kind of does open up like a whole realm of complexity, do we have a path in which that can still be accomplished with like order if your schema is designed properly? Like if the concepts are different enough that you're confident that order, that each type is like not really, there's not going to be a ton of ambiguity. Like, are we still enabling this to be done?
Yeah, I see that as one of the most valuable pieces of literal types, is it gives.
Right.
I think if you don't have them and you don't if you query type name, you can't send it back because it's going to be a different name type. So you can't query type name if you want to achieve that. And if you don't have the literal type or something like that is a clear discriminant, then yeah, what goes back may be interpreted as a cat instead of a dog, based on what you've queried, which would actually mutate what your data is interpreted to be. on the server. So yeah, it is an issue.
So this is a raw idea, but let's see. What if there was some other field on the output type, something like a under input name that would provide the mapping if there was a one-to-one mapping from like your output to your input, so that you could ask for that and then pop it up and use it in the mutation.
This won't be the first time I've said this, but input types and output types are different. Like there are fields on output types that won't be present on input types, like collect connections to other types and other such things. It's only in the very simplest of cases where they might actually be the same shape. So I don't think that there should be a GraphQL schema addition for input name where we actually say, look, if these two types are the same, because it really, if we want to do that, I think it would be better to actually come up with a new type that is isomorphic type that is both input and output. It gets rid of arguments. It works all the way through and can only reference other isomorphic input output.
This goes back to like a 5 or 6 year old topic of debate about whether input objects should have just been called structs. And, you know, structs can be part of output system or input system, but objects can't. That got confusing, so we bailed on it, but an interesting potential future thing to explore is introducing that and providing an easy migration from input to struct. I actually kind of really like this idea of, like, I can see why literal types could be broadly useful for creating structural uniqueness. Like I kind of think in hindsight, we over rely on the dunder type name. Like the original idea was the dunder type name was a tool for like development time tooling. And it ended up being like a clever hack that it was like a discriminant for output unions. And that was not the original intent. The original intent was to have this like structural interpretation of the output unions. But that's just generally not what people are doing. And I feel like if we had literal fields that would give you that might actually be a clever way to create this unity between inputs and outputs where you wanted it, and provide something other than type name in the cases where you wanted a different kind of discriminant.
Yeah. That's interesting. Yeah, there's something tempting about it. I want to contain that complexity of getting your map from the literal value to the type name.
Making it part of the schema design rather than something that's implicit.
Yeah.
Sorry, like just to expand on this idea of structs, it feels like structs would actually be an acceptable use case for the asterisk operator, which I'm very much against in general. But with a struct, like if you're saying concretely, this is effectively a leaf, and you know, you can concretely represent this thing, send it to the client and send it back to the server, that may well be a good solution to that problem for people who need that solution. And yeah, then you can literally receive it and send it straight back again.
But I'm here, maybe we should clarify what we mean by struct. To me, a struct also has field names and types. It's not like an any type.
Yeah, I mean, this was part of the debate on whether we should have a struct type, and part of the reason why we decided to not do it, to punt, is this question is really hard to answer. Should a struct be selectable in the same way that an object type is selectable, or should a struct be atomic? And you know, you just say like, okay, give me the animal, please, and it has like 5 fields, and it's a struct, and you get all 5 fields every time. And especially like interpreting the different, like when you say something is nullable or non-nullable, that means something different in an output versus input. Like all outputs are selectable. You can always just not ask for a field, and it won't come back to you. But inputs are about like requiredness, like whether you're required to provide a particular field or not. So interpreting types in an input or an output scenario are just different. And that's part of the reason why we ended up like this is getting too complicated and like how to interpret these things in both scenarios. So we punted on it. We'd have to answer those questions if we came back to it. But you're right, Benji, that it's like if you think of the world in terms of atomic objects, then it's not the worst thing in the world to have it as an input and an output, like
Well,
scalars.
since it only just came across my brain anyway, I've just realized that effectively this is solved now. It's a custom scalar using the specified by directive to indicate what its structure is. Like we could describe it through GraphQL, but like also it is potentially a solved problem, and you can treat it as an atom
So
and handle it in a scalar system.
Kind of, sort of, yeah.
we've tried to push people like in our world against that. Like you could always define a custom scalar that has like a map representation, and then but you basically, that's an escape hatch to get out of GraphQL, and so you no longer have any discoverability or tooling support. You know, it's just like saying like, get me out of GraphQL. I'm done with this shit. I just want JSON. Like,
Yeah,
but that's
custom
where the
scalars
trying to
are
avoid
built.
it.
specify comes in, right? Because it literally gives you the ability to specify it. So we could then come up with a community convention of specifying what the shape of those objects are, possibly even using its own GraphQL schema of some kind, and then potentially merge that back in a few years' time once the dust has settled.
We certainly could, but I think from a practical point of view, that the challenge of building generic tools like graphical or code generators that like have to now learn about this other thing. Like I think the custom scalars are most useful to describe it, the idea that the idea of it being a scalar isn't necessarily the important part. The idea is that it is a opaque piece to GraphQL. From GraphQL's point of view, it's just like an atomic opaque blob that serializes in some way. And then like we're deferring out to some other system to describe like how to interpret that thing. But if we want to consider it part of GraphQL and give it strong types and make it part of code generation and validation and all that good stuff, then it probably should just be part of GraphQL and not stick out to something else. But we're getting a little bit off off the topic, but that's okay.
So it seems like my read so far is like under type name is super straightforward. Doesn't have, as long as it's not the only thing that is in the toolbox, doesn't have a lot of downsides. The literal values are pretty interesting. They need to be contained in order to prevent explosions in complexity. And then the order seems like a somewhat reasonable fallback or just sort of kind of default mode behavior with some potential caveats and subtleties as to like the danger of them, slight danger.
Yes. I think that's the right read. There's one question here. I think a very root question is, where do we want to who gets the power? There's client, server, and there's spec. Should we constrain the power in the spec? Should we give clients this power? Should we give schema designers this power?
Interesting.
And ultimately, I think this is a balance on that what kind of view we want to take on this, because this option 3 is one extreme where we say that you have a ton of flexibility in how you describe your schema, especially if we add in this like 6th proposal, optional additional ways to do discriminants. Then we provide a ton of tools, but we don't provide a lot of schema validation on those tools. So we say like, the power is yours. Some of that power may include guns that are too powerful for you to hold onto, but it gives you a lot of flexibility in how you want to describe things. Whereas, especially proposals 1 and 2, and to some degree proposal 4, provide extreme schema validation rules that limit what you can and can't do. And in exchange for that power, you are forced into describing things in particular ways, which could cause issues for adoptability or expressibility when linking to other systems. I don't think either is wrong or right. I think they're just, there are different ways to view the values of this But it does give us some good homework. I know we're almost out of time, and I have something at the hour. So we should end on time. But I think there's a couple pieces of homework that we have. One is to write up this combined proposal 6. I can take a crack at it and add it to this doc, and then we can kind of riff on top of that. Another piece of homework is like going a little bit deeper into literal values. I think what might be helpful is write up the introspection for how literal values would get incorporated. A lot of things get more clear when you start writing out what your introspection schema looks like for these things. I don't know if there's something immediately obvious for type name that needs something similar, but maybe it'll be helpful also to explore like how that is implemented. And then I think the homework for one of is like, what are some of the forms that this could take? Is this just a directive, or could this be syntactical, or this idea of could we express input unions in one of the 1 through 4 or 6 scenarios? Is there like another variant on this that lets you like optionally move between, like, oh, there's a tag version and an untagged version? That's up to the schema designer to choose which to use. Or is this just like a completely separate thing? I think there's some interesting room to explore there as well. So that might land us with more proposals after this than we started with. That's not necessarily a bad thing, at least there's progression.
Lee, is it possible to get a copy of this recording?
I don't know if we're recording this or not.
It says it's recording.
It does? I'm not the one recording it then, if one of you are the hosts. But
I don't think I'm
Zoom
the
has
host,
been
but it's
super
definitely-
slow in recording, by the way. So assuming that it is recording, then I've seen like a 2-week backlog on getting videos back from Zoom because they've had an explosion in demand lately. So eventually, yes. But I'll copy and paste this like scratch sheet that I have written into somewhere where we can find it.
Okay, I'll look into the literals and explore that space a little more.
Sweet. I'll tackle doing a write-up of option 6. All right, folks, this was fun.
Yeah, it was.
Enjoy the rest of your day or evening.
Thanks, everyone.
Take
Bye.
care.
Yeah.
Bye.